Let's now move on to one of the most important topics in programming, which is exception handling. We'll discuss about different things related to exception handling. We'll talk about why exception handling is important and the different syntactical things involved in exception handling with Java. So things like finally, try without a catch, and those kind of things. We'll also look at the hierarchy of the exception handling classes. So we'll talk about error, exception, checked exception, unchecked exception, throws, and things like that. We'll also discuss about how do you create a custom exception, and also we would talk about a couple of new features which are introduced into Java, try with resources, and we'll end this section by talking about exception handling best practices. So why is exception handling really important? Thing is, a lot of applications are large and complex, and even for smaller applications, I've not really seen an application without defects. Defects and exceptions are quite common, and they happen every minute, every day. It's not really that bad programmers are the ones who create defects and exceptions. No, even good programmers write code that might have defects and that also can throw exceptions. So, what are the important things about exception handling? The thing about exception handling is there are two different parts to it for me. The first one is giving a proper message to the user. Whoever is the user of the application, whenever an exception happens, you give him a proper message. You give him a message saying, okay, this an exception happened. If you want to find out more, talk to the tech support or something of that kind. One of the good practices that we follow is to give a unique identifier to the exception. We tell the user to say, contact tech support with this specific unique identifier. The other important part is to have enough information for your support team or the support developer to debug the problem. So these are the two important parts. The first one is a friendly message to the user. The second one is enough information for support developer to debug the problem. So what do we mean by enough information? We mean a proper stack trace, a proper explanation of what context this application happened in, and also log the unique identifier which was given to the user in the logs, so that somebody can search for it in the log and find out that unique identifier and get all the information about exception. The two things that are really important about exception handling is giving a proper message to the user and making sure that there is enough information available for the support developer or support team to fix the problem or to identify what is the root cause of this particular problem. Exception handling in all languages, in most of the languages, follows a specific design pattern. The design pattern which is talked about is chain of responsibility. So, for example, look at it in here. So, a main method is calling method 1. Method 1 is calling method 2. And method 2 is throwing an exception. str is equal to null, str.toString obviously throws an exception. So, the way it would be handled in Java is that this method 2 is throwing an exception. Where is this called from? This is called from method 1. There is no try catch in method 2. So it does not know how to handle the exception which is thrown. So what it does do? What does it do? It says, okay, I don't know how to handle this. Method 1, you are calling me, so you try and handle this. So method 1 sees, oh, method 2 is called here. Do I have a try catch block? Nope. I don't know how to handle this exception. So I need to return it back to the calling method. It goes back to main. Main says, okay, do I have a try catch? No, I don't have a try catch. I don't know how to handle this. So I'll throw it out. So what would happen is this will be the output. So you'd see the output saying exception in method, and you'd see the complete stack trace. You are seeing that, okay, main method is like the starting from the first line. So method 2 is the one which is throwing it. You can see which line of the code which is throwing, and then it went to method 1, and then it went to main. And so you can see the entire stack trace which resulted in this exception when we do something called e.print stack trace. This flow of exception from one method to the calling method is one of the things which are defined in the chain of responsibility pattern. So basically, chain of responsibility pattern is a way of passing a request between a chain of objects. So here method 2 is an one of the things in the chain. Method 1 is one of the things in the chain. Main is the last thing in the chain. So whenever an exception is thrown, what we are doing is, hey method 2, do you know how to handle this? Hey method 1, do you know how to handle this? Hey main, do you know how to handle this? So that's kind of the message passing which happens, and in this specific example there is no exception handling defined anywhere, so it is thrown out. A good example of the chain of responsibility pattern is like a loan or a leave approval process. Um, f- let's take a loan approval process. First, it goes to the clerk. So, if the amount requested is higher than what he can approve, it goes to his manager. Probably, if it's greater than even his approval limits, it would probably go to his director, and so on and so forth until it's approved or rejected. Same is the case with exception handling, and this pattern is called chain of responsibility pattern. What is the need for the finally block? You are handling an exception, so there's a try catch block with exception handling, and you're logging the exception, you're printing the exception to the trace. But why do you need finally? What is the role that finally plays in a try catch block? That's the question. So, for example, look at this method. What does this method do? So, we are creating a connection. We are calling connection.open. So, the connection is opened, and we are doing a little bit of logic in there. Here, we hard coded up exception. So, this exception would cause an exception to be thrown, and we have the connection.close code right after this. So, what happened when the exception is thrown? Will the connection.close get executed? The connection.close will not be executed because this line threw an exception. So we would directly go into the catch block, and the like we let's say, I mean, in a really well implemented code, this would be either logging it to a log or printing the stack trace or something of that kind. So we go to the catch block and go out. So the connection which is opened is not really closed. So the connection is leaked, and that's a problem. So that's where the finally block comes in. So what we do is, instead of doing connection.close directly in the try, what we would do is we would move it to finally. What would happen is, whether an exception is thrown or not, the connection.close would be called and the connection will be closed. So finally is basically used to do any cleanup that you would want to do, whether an exception occurred or not. So the great thing about a finally is that it would be executed irrespective of whether an exception occurred or not. If you write the code down here, somewhere down here, then what would happen? If an exception happens, that code is not executed. So that's basically when you use finally. We were discussing that finally is always executed, whether an exception is thrown or not. So what are the chances? I mean, what are the scenarios where finally is not executed? Basically, there are two scenarios. So let's say if I have 10 lines in finally, and the second line in finally also throws an exception. So there's an exception inside the finally block itself. Then the rest of the lines in finally are not executed. Or the JVM crashes. So let's say it's crashing with an out of memory exception or something of that kind. In that kind of a scenario also, your finally will not be executed. Look at this program below. Will finally be executed in this program. I mean, the trick is there's a return here. So in the catch, what we are doing is system.out.println and doing a return. So will finally get executed. The answer is yes. It finally gets executed and the connection gets closed, even if there's a return statement. Is try without a catch allowed? Yes, it is. So you can see there's a try and there's just a finally, there's no catch in here. So that's allowed. A try without a catch and finally, so a try without catch and without finally is not really allowed. So you should either have a catch or a finally or have both. You cannot have a try without having either of a catch or a finally. Welcome back. In the previous video, we looked at the tricks around try, catch, finally, and things like that. And in this video, let's focus on the hierarchy of exception handling classes. There are a lot of terminologies which are used around exception handling classes. Throwable, error, exception, runtime exception, checked exception, unchecked exception. Oh my god. So many things that we would want to clarify during this specific video. So let's start with the hierarchy of exception handling classes. At the top of the exception handling or the error handling hierarchy is throwable. So throwable is the topmost class. And there are two types of important classes which extend throwable. One is error, the other one is exception. So error is basically anything that you cannot handle, anything that programmer can never be able to handle, that's an error. So basically you can think of things like out of memory. If JVM runs out of memory, there is nothing a programmer can do about it. So those kind of things are called errors. Exceptions are those things that programmer can do something about. I am trying to read a file and file is not found. So you can probably retry, or you can probably try for another file or something of that kind. Those are the things which are called exceptions. Exceptions again are classified into two types. One is checked exceptions and unchecked exceptions. Any method that is throwing an exception in Java has two options. Either it can say I'm throwing a checked exception or an unchecked exception. A method will throw a checked exception when it wants the calling method, whichever method is calling that method, it wants that method to know that I am throwing an exception, do something about it. So if I want the calling method to try and handle this exception or do something about this exception or to know about this exception, then I would use something called a checked exception. Unchecked exceptions are when I'm throwing an exception, but I'm not sure if the calling method would be able to do anything about it. I don't really want the calling method to mandatorily handle that exception. In those kind of scenarios, I would throw an unchecked exception. So when I'm throwing a checked exception, then whoever is calling me needs to definitely handle that exception or throw it. When I'm throwing an unchecked exception, then the calling method does not need to do anything about that specific exception. We talked about throwable. We said there are two kinds of things at the highest level, right? Error, exception. Error is those things which the programmer can do nothing about. So out of memory exception. Exceptions are those things which are things which a programmer might be able to do something about. And exceptions are of two types that we talked about: checked exception and unchecked exception. The thing is, checked exception and unchecked exceptions are not really classes in Java. So they are not really Java classes. Basically, the way it works is there is something called a runtime exception. So runtime exception again extends exception. Any exception that extends runtime exception is an unchecked exception. So if you look at it here, I am extending a runtime exception, it's an unchecked exception. So anything which extends runtime exception or a class that extends runtime exception is a unchecked exception. Any exception class which does not extend runtime exception but extends exception directly is a checked exception. So if I want my method, my exception to be definitely handled by the methods which are calling me, then I would create a checked exception. So what I would do is I would directly extend exception or extend a class which is extending exception. Any exception which is not in the runtime exception hierarchy is a checked exception, and any exception which is in the runtime exception hierarchy of classes is a unchecked exception. So that's at a high level. To summarize the checked and unchecked exception part of it, it's basically if you want your calling method to handle an exception, to mandatorily handle the exception that you are throwing, then you would throw a checked exception. You can create a checked exception by directly extending exception or extending something which is already extending exception other than the runtime exception. But if I don't want the calling methods to do anything about the exceptions that I am throwing, then I would actually extend runtime exception or one of the things that extends runtime exception, and then I would be called a unchecked exception. Since we now understand the basic concepts, a lot of these questions will be very simple to answer. What is the difference between error and exception? Stack overflow, out of memory, all these are things which programmer cannot do anything about. These are errors. Exception is when the programmer can handle the exception. What is the difference between checked exception and unchecked exception? Runtime exception and classes that extend runtime exception are called unchecked exceptions. What are unchecked exceptions? Other exception classes which do not fit this definition. So Anything which is not runtime exception or extending runtime exception but an exception, then that's a checked exception. Coming to how you can throw an exception from a method. So there's a specific situation in which I would want to throw an exception. So here the business logic which we are doing in this example is that we are adding two amounts. So what we are doing is amount adder dot add amounts, new amount of rupee comma 5 and dollar comma 5. And as of now my program is not ready to accept different currencies. So it does not know how to convert dollar to rupee or rupee to dollar. So what we are doing is, if the currencies do not match, we want to throw an exception. So what we are doing is, if the currencies do not match, then we are throwing something called new runtime exception, currencies don't match. So this is how you throw an exception. The highlighted line shows how you throw a exception. So it's basically throw new runtime exception of currencies don't match. I could have actually used exception also. I've chosen to use runtime exception here, but I could have used exception also. But how do I decide whether to choose exception or runtime exception? We'll discuss that a little later. But to be really simple, this is how you would throw a exception from a specific method. If you look at this method, because I'm passing in different currencies, this would throw an exception. It says currencies don't match. That's the exception that I'm passing in, and it would show the trace as well. What would happen when you throw a checked exception from a method? If you looked at this exception, we are creating a runtime exception. Runtime exception is a unchecked exception. So because it's an unchecked exception, the calling method, which is the method which is calling this, the main method. The main method does not need to do anything about this runtime exception. So what, like, it does not even need to worry about putting a try catch around it or throwing something out. However, when you're throwing a checked exception, the situation would change. For example, now if I'm changing the runtime exception in the previous example to exception, what would happen? What would happen is, you'd get a compiler error. The compiler error would say unhandled exception type exception. Basically what would happen is that this line would start giving you an exception. So you have two options: either you can handle this or you can throw it. Those are the options that we would discuss in the next thing. So what are the options you have to eliminate compilation errors when handling checked exceptions? This example is now throwing a checked exception because I'm throwing a exception. So the first thing I have to do when I actually am throwing an exception is that I have to do a throws. So I would need to say throws exception, because I'm throwing a checked exception, I need to declare in my definition that I would be throwing a exception. So here, if you look at it now, the add method is saying, okay, I'm throwing an exception. So that's basically what the add method is throwing. Any method which throws a checked exception should say in its signature that it is throwing an exception. Once you add this line in code, then you would see that the main method would start having a compilation error, because the main method is now calling a method which is throwing an exception. When a method is throwing an exception, that's basically a checked exception. It means this method has two options now. Main has two options. Main can either throw an exception, so it can say I might throw an exception, or the other option it has to put a try catch block around it. So it can say I will handle the exception myself. So it's doing a try catch and actually printing out something. This is not really a good practice that I'm actually just doing a system.out.println, because if the exception happens, I have no idea what the exception which is thrown in here is. Either I have to print this track trace, ideally I have to even put it to a logger or an exception manager or something of that kind. So the two options that we have when we are dealing with a method which is throwing a checked exception. So the add amounts now is throwing a checked exception. So anything which is not a runtime exception is a checked exception. So this is throwing a checked exception. So the main method which is calling that has two options. Either it can throw the exception out. So the main method itself saying I will throw an exception, I don't want to handle it. Or it can handle it by using a try catch block. To summarize, if you want the calling method not to worry about the exception that you are throwing, then you would create a unchecked exception like a new runtime exception. Then main does not need to worry about what you are throwing, because this is throwing a just a runtime exception which is an unchecked exception. So main does not need to worry about that at all. But if I'm throwing a checked exception like a new exception, then the first thing is the method itself should say I'm throwing an exception. So when I'm throwing an exception, I have to declare saying I'm throwing an exception. Not only that, the calling methods should decide whether they throw the exception or whether they would want to handle the exception as it is in here. So you cannot ignore a checked exception. So if a method you are calling is throwing a checked exception, then you should either declare it by saying throws, or you would need to handle it by using a try catch block. So that's the summary of checked exception and unchecked exceptions. Now that we saw how to throw an exception and we saw how to throw runtime and normal exception, there's an option even to create custom exceptions. So how do we throw a custom exception? For example, in the scenario before, we would ideally want to throw an exception saying currencies do not match exception. So how do I do that? So the way you can create a sub exception, the way you create a custom exception is in two ways. Either you can extend exception, then you're creating a checked exception, or the other option you would see a little below is to extend a runtime exception. Then you are creating a unchecked exception. Here, if you see, I'm creating a checked currencies do not match exception, extending exception. So this is a checked exception. So what happens when I'm throwing a checked exception? Then the method which is throwing that checked exception has to declare that I'm throwing a currencies do not match exception. So I have to mandatorily declare that I'm throwing an exception. And also the calling methods should either handle it or should throw it out. So either main has the option to say throws currencies do not match exception, or it can handle that and kind of print it to the stack trace, or ideally it should be using some logger or something of that kind. The other option we have to create a custom exception is to extend runtime exception. The thing about runtime exception is the fact that we are now creating a unchecked exception, and when we create an unchecked exception, we don't really need to handle it. So if you see the code, then you don't need to really define that it is throwing an currencies do not match exception, and even the main method does not need to handle it because this is an unchecked exception. So if so it's basically we are saying that the calling method does not mandatorily need to handle it. But if main wants to go ahead and try and handle it, it can do that. I mean, main always has the option of doing a try catch around this and catching this exception, but it is not mandatory. Let's now move on to a few code examples. What is the output of program below? So amount adder dot add amounts, and I'm catching an exception and a currencies do not match exception. The answer is this would result in a compilation error. The order of the exception should be from specific to generic. So the first exceptions in the first catches should be all specific, and the later ones should be more generic. So here if you look at it, currencies do not match exception is a specific exception. Exception is general, every exception. So ideally this catch should be below the catch for currencies do not match exception. The next question is how do you handle multiple exception types with same exception handling block? If I want to handle IO exception and SQL exception the same way, how do I do that? So this was not really possible in earlier versions of Java. In earlier versions of Java, what we used to do is we used to extract it to a method and call the method from both the catch blocks. Now with Java 7 and beyond, it's possible. So the way we do that is using a try catch with multiple exception. The syntax is IO exception or SQL exception. So IO exception or SQL exception, this block would handle it. So this block would handle the logic for that. This is also, the try with resources is also a recent entry into Java with Java 7. What it enables us to do is we typically write try, we open a resource, and then in the finally we close the resource. So it's kind of logic which we keep repeating everywhere. So Java came up with this thing called try with resources. So inside the try, I am putting the resource which I would want to hand, I mean, which I would want the try catch to handle. So what we are doing is try and creating the resource here. If an exception is thrown, the close connection method on this is automatically called. The way this is done is by using an interface called autoclosable. So any class which I would want to use it in a try with resource, the buffer reader, for example, here implements an interface called autoclosable. So what happens is if an exception is thrown, then Java knows that there's a close method which is defined on this. So Java would directly invoke br.close to close the connection or to close the buffered reader in this particular instance. So this is try with resources. The summary is the try with resources helps us in writing simpler code because I don't need to have a finally and call the close in there and have lines before to open the resource and things like that. And the way try with resources is really implemented is by making the classes which we want to use in try with resources to extend an interface called autoclosable, and they also implement the close method and they define how they needs to be closed. The close method would contain the logic if there is an exception or there is not an exception. How do you close down the buffer reader? Until now, we looked at a lot of things related to exception handling. What are the exception handling best practices? If you looked at some of the methods that we created earlier, because of the space constraints, we were not really following all the exception handling good practices. Some of the places we were hiding the exceptions, we were not throwing them out, or we were not really logging them completely. So yeah, here are a list of best practices that you need to always follow in your real world projects. So the first one is never hide exceptions. That's a sin. So hiding exceptions is a big sin, because if you hide the exceptions, then if something goes wrong, then nobody knows what is going wrong. You have to definitely log the exception or store it somewhere where you can look at and find out what the exception which was thrown is. The second thing is do not use it for flow control. Exception handling is just in case of an exception. Do not use exception handling to control flow in an program. Exception handling is not a free thing. I mean, it definitely has a lot of significant performance impact. Also, whenever you write code for exception handling, always think about the user and the support developers. So think, okay, if this exception happens, what does the user want to see? So what can the user do about it? What information can I give it to the user of the application? The second person you always need to think about whenever you're handling exceptions is the support developer. What information does the support developer need to be able to handle this exception? Let's say this exception occurs in production. What information do I need for me to be able to easily identify the root cause of this exception and identify the scenario under which this exception is occurring? So think about that and make sure that you're giving enough information that would help this user as well as the support developer. The information which user needs will be different from that of the support developer, right? A user will not be able to understand anything about your stack trace or anything. All that he cares about is high level. So who can help him with resolving this error? A support developer is the one who would really be concerned about the details. Also, there are security things. You don't want to show the exception trace to your user because there might be some secure information which is in there which you don't want to really show to the user. Also think about the calling method. So this is when you try and make the decision whether you want to create a checked exception or an unchecked exception. So always think, can the calling method do something about this exception? I mean, can it handle the exception and do something good about it? If it cannot do anything about it, then it's better to create an unchecked exception. If you look at Spring Framework, it chooses to make most of the exceptions, most of the JDBC exceptions as unchecked exceptions, because there is nothing you would be able to do about a JDBC exception. If a JDBC exception is thrown, then all that we can do is throw a sample message to the user saying, okay, some database exception happened, and then you would need the support developer to go and look at what the cause of the exception is. There is no way a calling method will be able to see a JDBC exception and take a preventive action. So in those kind of situations, it's better to use an unchecked exception than a checked exception. So always think about whether you want to create a checked exception, unchecked exception, whether you want the calling method to know that you are throwing an exception, can the calling method do something about that exception, and these kind of things. And the last important best practice is have global exception handling. If you have multiple layers, let's say I have a web layer, a business layer, a data layer, and a lot of things like this, if a data layer is having throwing an exception, don't have logic to handle that exception in data layer, don't have and business layer and web layer. You don't need to have it everywhere, because web is the part which starts out with the request. You can have a global exception handling at the web level, and if there is any exception in the chain, then the web level can handle it and show a proper message to the user. I mean, this is of course except for the scenarios where there's a business logic which is failing and you want to write some business logic to handle that exception or counter that exception. In that kind of a scenarios, then you can write exception handling logic in the specific layer. But in all other kind of scenarios where all that I want to do is show a generic message to the user, don't have your exception handling code present all through the code. Have just some global exception handling mechanism to handle that and leave the rest of the code free of exception handling. Okay, there you go. That's a lot of discussion about exception handling. We started with try catch. Finally, we moved into the hierarchy of exception related classes. We looked at how to create custom exceptions, and now we were discussing about the exception handling best practices. So that's a lot of ground that we covered in this specific section. If you look at the workspace, there are two examples: exception handling example 1 and exception handling example 2. You have a lot of code in here which explains how you'd want to handle exceptions and how the exception handling hierarchy and things like that. I would really recommend you to do this as an exercise. Just go through this piece of code and try and understand everything that is happening in these two classes, because it would give you a clear idea of everything that is related to exception handling. So good luck, and I'll see you in the next video.